Alright, I really thought the last one was going to be the last video, but then I clicked the next page and then there was more, so here we go. That last video, I was struggling. There were interrupt cuts and all kinds of things. Let me know if I need to record that, please. Re-record that. Alright, so let's look at this. 1,000-kilogram car and 2,000-kilogram truck. They collide and they stick together. That is so important to know. We have to know that they stick together as a single object. That means our masses combine. If the car is moving at 30 meters per second, well, let's hold on because it looks like we're doing multiple situations here. Let's remember that conservation of momentum means the initial momentum, or the momentum in the beginning, equals the momentum at the end. Okay, so if the car is moving at 30 meters per second and hits the truck, which is at rest, oh good, that means something's going to cancel out. How fast does the car-truck combination move after the collision? Alright, so because they're sticking together, I'm going to expand this a little bit more. So we have momentum of the car in the beginning, plus the momentum of the truck in the beginning, equals the momentum of the car, stick together, Mr. Scapetus, the car-truck combo. Okay, and if I expand that out a little bit more, it's going to be mass of the car times the initial speed of the car plus mass of the truck times the initial speed of the truck equals the mass of the car plus the mass of the truck times the final speed. Okay, so there's our general equation. So let's dig into A. If the car is moving at 30 meters per second and hits the truck, which is at rest, how fast does the car-truck combination move after the collision? So in this situation, we're looking for the final speed here. So we're just going to be inputting values. We know the mass of the truck is 2,000, the mass of the car is 1,000. The truck is initially at rest. Truck is moving at 30 meters per second and is 2,000. The car is at rest. So 0 velocity here, 0 times the mass of the car, that goes away, equals the mass of the car, which is 1,000, plus 2,000. I think that's 3,000. Please check on your calculator. I don't know. And we're solving for the final velocity. So we're going to divide each side by 3,000. And this is 60,000 divided by 30,000. That tells us the car-truck combination will be moving at 20 meters per second. Cool. Hopefully you got that. If not, rewind. Go back. Let's clear this up because I think this equation is going to continue to work. And I don't want to have to go through rewriting all of it. If the truck is moving at 30 meters per second and hits the car, which is at rest. Oh, that's what we just did. We just did B on accident. Whoops! Good for us. We're ahead, but not really. Alright, for part A, if the car is moving at 30 meters per second, so the car is 1,000 kilograms moving at 30 meters per second. The truck is at rest, so the truck goes away. I think if you rewind that, you'll see that I was a little confused by myself because I thought for sure that I had read the truck was at rest, and then I read the car, which is at rest. I'm so sorry. Let's see. So we have the mass of the car and truck, which we said is 3,000, and we're looking for the total speed at the end. So again, we're going to just divide out 3,000. This is 30,000, so our final velocity here is going to be 10 meters per second. 10 meters per second for part A, 20 meters per second for part B. So which one of those is more deadly, if the car's moving or if the truck's moving? VF equals 10 meters per second. VF equals 20 meters per second. All right, so who is more injured, the truck driver when the car hits the truck, or the car driver when the truck hits the car? So looking at this, we know that the injuries occur most when there is a sudden change in velocity in a collision. So if we're sitting at rest, then we're going all the way up to 20 meters per second. Meanwhile, the car was moving at 30 meters per second and drops down to 10 meters per second. So our change in velocity here is 10 meters per second for the car driver, and our change in velocity here for the car driver is 20 meters per second. So which one is worse? It's that one. So it's when the truck hits car. So when the truck hits the car, the person driving the car is going to be in so much more damage than if the car had hit the truck. Who's more injured? The car driver when the car hits the truck, or the car driver when the truck hits the car? Truck hits the car. Every single time, we're going to be dealing with that same change in velocity for that car driver. So it's going to hurt. If you were sitting there at rest and a truck comes up behind and they were texting and they didn't notice the red light, so they smash into the back of your car, that's going to leave you with some really bad injuries and is also one of the big drivers in all of the distracted driving things that we talk about. That's it.